Okay, we're going to look at putting together all the conics now. And so these questions on this page, they don't say what the actual graph is, and we're just kind of combining all the conics together. So part of what your goal is to figure out which ones are which. So you're going to identify as a circle, an ellipse, a hyperbola, or a parabola. If the equation is a circle, remember the key features would be having a center and a radius. If it's an ellipse, you're going to identify the center, the vertices, the endpoints of the minor axis, the foci, and then we can also find eccentricity. So remember that eccentricity is the distance to the focus over the distance to our vertex. If you end up having a hyperbola, you're going to identify the same thing, center and vertices and foci, but also the equations of the asymptotes, and we're going to actually skip out on that eccentricity for a hyperbola. Then if the equation represents a parabola, we're going to identify the vertex, the focus, the equation of the directrix, and the equation for the axis of symmetry. So we'll identify them and then be able to identify the pieces. So the first one, when I look at number 1 there, I see an x squared and I see a y squared. So I know that it's going to be either a circle, ellipse, or hyperbola. It can't be a parabola because that only has one thing squared. I also notice that it has addition between our two squares. And so that's telling me that I have either an ellipse or a circle because I do not have a minus between them, which makes it the hyperbola. So I'm going to work on completing the square so I can see if it's going to end up being a circle or an ellipse. So I have 5x squared plus 40x, putting our x's together. Then I'm going to put my y's together. 8y squared minus 16y. And then that leaves our 48 equal to 0 just hanging out. So my beginning part here has a 5, so I need to factor that 5 out. I'm left with x squared plus 8x. I'm going to add something, minus something to complete the square. Then for my next part with the y's, I have an 8 in the front, so I'm going to have to factor out that positive 8. I'll be left with y squared minus 2y. I'm going to add something, minus something, and then I still have my 48 equals 0. So then let's see what we'll add to complete the square. We'll take 8, divide that by 2, which is 4. So we'll take 4 squared, which will make 16, minus 16. We'll take negative 2, divide that by 2, that's negative 1. So negative 1 squared is 1, and then 1. And the whole purpose in that was so the first 3 terms will factor to that perfect square, x plus 4 squared. We'll bring the 5 still down, and then negative 16 needs to get kicked out. So multiplying it by 5, which means we have a minus 80 sitting there. Then we're going to take the y's, again the first 3 terms, factor that to a y minus 1 squared. Plus 8 is still hanging out there. We need to kick out the minus 1 by multiplying, so we get negative 8 plus 48 equal to 0. So I'm going to combine my like terms, which is the negative 80, the negative 8, and the 48. So that's going to become a negative 40. So I have 5 times x plus 4 squared plus 8 times y minus 1 squared minus, let's see, the negative 80 with the negative 8 and 48 was negative 40 equal to 0. So then I'm going to move my 40 over, so we're left with 5 times x plus 4 squared plus 8 times y minus 1 squared equal to 40. So right now it doesn't look like a circle because I have a 5 and an 8 here. And so I'm thinking I need to divide by the 40 to make it equal 1. And so when I divide by 40, 40 is 8 times 5 and 8 times 5. So my 5's will cancel. So I'll be left with just x plus 4 squared over 8 plus the 8's will cancel. So we're going to be left with y minus 1 squared over 5 equal to 1. So we've written the equation in our pretty form, and you can recognize a lot more easily now that that is for sure an ellipse. So we need to find all of the details. So you might need a separate sheet of paper for the rest of this one. So in order to find the details, let's see, what do we need to know? I'm looking back up at the ellipse. So we had to find the center. So I know that our center for our equation is, let's see, that plus 4 means left 4. The minus 1 means up 1. So left 4 and up 1. We have our center is negative 4, 1. A few more details, let's see. Because the 8 in the bottom of the fraction is underneath there, square root of 8, which square root of 8, there's a 4 in there. I'm going to be able to simplify that to be 2 radical 2. That's how much we're moving left and right because that's under the x. When I look at the denominator under the y, that's going to be the square root of 5, which can't simplify, but that's how much we go up and down. So let's kind of graph this thing so we can see better what's happening. Negative 4 up 1 has our center right there, and we're going to go left and right 2 square roots of 2 or square root of 8. Well, square root of 8 is a little less than square root of 9, so it's left and right 3. So 1, 2, 3, a little less than 3. 1, 2, a little less than 3. And then we're going to go up and down square root 5. That's just a little more than 2. So a little more than 2. A little more. Okay, so because the 8 is a bigger number, we know that we're supposed to be just a little bit wider. And so that also means that this is my vertex and this is my vertex. So to find the vertices, I can think that I had my start at negative 4, 1, and I went left and right radical 8, or 2 radical 2. So this will be negative 4 plus the 2 radical 2, and negative 4 minus the 2 radical 2. The next thing that I have after finding those vertices is the endpoints of the minor axis. So the endpoints, so that's going to be how I went up and down. So I went up and down radical 5. So from the center, I went up and down. That's going to affect my y values. So up radical 5 and then minus the radical 5. So I can write that as negative 4, 1 plus square root 5, negative 4, 1 minus the square root of 5. And so those are the endpoints of the minor axis. The next thing I need to find is my foci. So the foci are found for an ellipse by taking c squared equals a squared minus b squared, or the big guy minus the little guy. And so that will be 8 minus 5, so we'll get 3. So that means that c will be the square root of 3. Again, they are going to be on the major axis, which in this case is that horizontal guy. So I'm talking about going left and right radical 3, so a little less than 2. So 1, oopsie, wrong one. Undo that. Go back to my pen. So left and right a little more than 2. So there's a focus, and there's a focus, a little less than 2. So that's left and right, that radical 3. So I'm going to scroll down here. If I have my center again at negative 4, 1, I want to go left and right, that radical 3. So my foci are going to be negative 4 plus radical 3, comma 1, and negative 4 minus radical 3, comma 1. Those are the foci. And I got one more detail. A lot of details here. That's eccentricity. So the eccentricity for the ellipse, that's how long or ovally this guy is, which it looks pretty not too elongated on this one, but it's going to be equal to c over a, where c is the distance to the focus, which is square root of 3, and a is our bigger length, which is going to be that radical 8. Or we could write it as radical 3 over 2 radical 2, which is approximately 0.61 if I did that right. Okay, that was a little long over there. Let's look at question 2. Now question 2 looks really nice after all that hard work because we have it already in the form that we need. So if you look at it, we see a minus, you see we have y squareds and x squareds, and we have equal to 1. So we know that that's going to be the hyperbola. And so a reminder for our hyperbola, if you see that y is first in front of that minus, we know that it's going to be opening up vertically. Let's see, what other details we know? The -2 here is telling us to go up 2 to find our center, and the +3 is telling us to go left 3. So our center for our hyperbola is going to be -3, 2. And we also know that because the 9 is underneath the y, that vertically from there, we're going to go the square root of 9, which is 3. And we're going to go left and right because 16 is under x, the square root of 16, which is 4. So to get going on the graph here, I'm going to put some markings. It's going to be a little sketch. So I'm going to start by plotting my center on there, which is -3, 2. So -1, 2, 3, up 2. So my center. And then I go left and right 4. 1, 2, 3, 4. 1, 2, 3, 4. And then up and down 3. 1, 2, 3. 1, 2, 3. Now for a hyperbola, it does not matter which length is longer, but what does matter is which variable came first. So I already talked about that the y comes first, so it's opening up and down, which means that my transverse axis is vertical. So my vertices are going to be these two guys. And the other two dots that help me form the rectangle, we won't have to identify those guys. So my vertices, again, we went up and down 3. So up and down 3 would mean plus and minus 3 to our y values. So plus and minus 3. So it'll be -3, 2 plus 3 is 5. And if I subtract 3, that'll put me at -1, which you can check that those match up with our picture. Now I need to put my asymptotes on here. They got to go through the corners of that rectangle I made and through the center. And then that's going to help me to build my graph. So my graph has to follow the asymptotes and go through the two vertices. So there's my picture of my hyperbola. So the next thing that I will need to find is my foci. So the foci, remember the equation is going to have the a squared plus the b squared because I need to be able to open up to my foci so it doesn't have subtraction like the ellipse did. So that will be the 16 plus the 9, doesn't matter big, small, because we're adding, so it'll be 25. So that means that c squared equals 25, so c will be the square root of 25, which is 5. So to graph my foci, again, I start at the center, everything's based off the center. I'm going to go up 1, 2, 3, 4, 5. There's a focus. And then 1, 2, 3, 4, 5. There's my other focus. So if I want to write the equation, or not the equation, but the coordinates for them, it's like, okay, I'm at the center, -3, 2. I'm going to add and subtract the 5 to go up and down. So my coordinates will be -3, 2 plus 5 is 7, and -3, 2 minus 5 is -3, and you could verify that those are where I just plotted those points. So let's see, are there any other details I'm missing? I'm going to go back to my directions. Okay, hyperbola had a center, we got that. Vertices, foci, and the equations of asymptotes. We skipped the eccentricity. Eccentricity really just says how wide these open. We're not going to worry about that though. So we need the equations of the asymptotes. So to do that, all we need to do is figure out the slope of the line. And we already know the transformation. So we're looking at like y equals mx. So m, that's the rise over run. So how we were able to make the asymptotes, or actually the box for our rectangle, was going up 3, which was that number. And then you can see we went left and right 4. So our slope is going to be 3 over 4. And our transformations, well, it's going to be y minus 2 equals 3/4 x plus 3. And we also need the other side, so we're going to write plus and minus. So there's our asymptote, or you can write it if you want it just y equals plus minus 3/4 x plus 3 plus 2. Either of those would be perfect. Okay, we're going to skip down to question number 3. So when I'm starting to look at that, I see an x squared and I see a y squared. I see an addition. So again, that's making me think that I have an ellipse or a circle going on here. So the only way I know that it's going to be a circle is if I end up having the distances being the same, going left and right and up and down. So I'm going to just start to try and write it in the pretty form so I can identify whether that's happening or not. So I'm going to put my x's together, x squared plus 10x. Then I'll put my y's, y squared plus, so not plus, it's minus 6y. And then I still have my plus 25 equal to 0. So I want to take these first two terms. Now it's nice, there's no coefficient like we've been having. So we're going to take x squared plus 10x. You're going to add something, minus something to complete that square. With our y's, again, no coefficient, so we're just going to have our y squared minus 6y, add something, minus something to complete the square. And so the thing that we're going to add, you take the 10, take half of it, which will get you 5, and then 5 squared is what goes in here, 25 minus 25. We take half of 6, which is negative 3. We'll take that and square, we get a 9 and a 9. So we have the first 3 terms here will become x plus 5. And we don't have to multiply the negative 25 by anything. It's still just kind of hanging out. I'm going to write it down. Then the first 3 terms I was working with the y's, that's going to become y minus 3 squared. And the minus 9 again, still just hanging out. So it looks like I am left with, let's see, combining like terms, negative 25, negative 9 plus 25. Well, the 25s would cancel. So we're just going to have x plus 5 squared plus y minus 3 squared minus 9 equal to 0. So we can move the 9 over. And so I have x plus 5 squared plus y minus 3 squared equal to 9. Now this one's a circle. I know that it's not in the form of an ellipse, or doesn't have to be equal to 1 anyway, because there was none of that numbers in the front of these guys. So as it is, it's a circle. And for a circle, let's go back to our direction. For a circle, all we need to identify is the center and the radius. So going back, here we go. We know already that this x plus 5 is telling us to go left 5, and the minus 3 is telling us to go up 3. So our center will be negative 5, 3, and our radius will be the square root of 9, because 9 is equal to the radius squared, so we're going to get our radius is 3. And it doesn't say that we have to graph it, but if I was going to graph it, I would go to my center, negative 5, up 3, and then I'm going to move left and right 3. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and that's my circle. Now, if you're not sure about any of your graph, or you're completing the square or anything like that, just a couple little side checks for you is that, again, this is the set. What I drew in blue is a set of all points that satisfy the equation. So if I pick a point on here, let's say I could pick that point. Well, even easier would be maybe this point. And that's negative 5, 0. This must satisfy our equation. It must satisfy the one that we wrote nicely. It also needs to satisfy our original equation. So you can check that it does. That it satisfies both of those. So just to check, in the beginning equation, if I replace my x with negative 5, that's going to be negative 5 squared plus y squared is 0 squared plus 10 times negative 5 minus 6 times 0 plus 25. All the zeros will go away. This will be a 25. This will be minus 50. Plus 25, it does equal 0. So it satisfies that first equation. So that's a good kind of start to checking that you were correct. Okay, we got one more here. So the only conic we haven't done yet is a parabola. So this looks like it will be a parabola. And the reason I know that just by looking at the equation is because I only have one quantity squared. This x minus 3 is not squared. So I know it's a parabola. And parabolas can either face up and down, or they'll go left and right, but it depends on what variable squared. So if we have y squared equals 4px versus x squared equals 4py. So the way I remember is that x squared is our regular functions that we're used to. So the x squared being like this means we're going to have either a downward or upward facing parabola. If you have the y squared, then it's going to be a parabola pointed left, or it could be a parabola pointed right. So I have y squared here, so I'm picturing that first equation, 4px. And I see my 4p then would have to be the -4. I have the +2 next to the y. That's going to mean I'm going to moving down, which would be down -2. And I'm going to be moving to the right 3. So my vertex is going to be 3, -2. And I'm y squared, let's see, so I have to either open up to the left or to the right, but I know that my 4p is -4, so to solve that, I end up that p equals -1. So that negative tells me I'm being reflected, so I'm going to the left. So I'm going to plot what I have here so far. So with my vertex, 1, 2, 3, down 2, here's my vertex. And that -1 tells me that I'm going to be opening up this direction, and there's my focus. I also know my directrix will be 1 backwards. So I have my focus is going to be to the left 1 from my vertex. So that will be at 2, -2. And the directrix was to the right 1, which puts it at x equals 3. So then the other details, let's see, what else do I need to know for a parabola? Vertex, focus, equation of directrix, and the equation of symmetry. It didn't ask me for it, but the other detail I'm used to is doing the focal diameter. And so I want to plot that so I can finish my graph here. So the focal diameter is telling me from my focus I need to go 2p, so 2 that way and 2 that way, which makes a total of 4, which that distance 4 will always match up with that number. And so I have my graph going this way. You should be able to identify the focal diameter as well, which is 4, and it helps to graph the picture. And so the last thing that I'm missing, my axis of symmetry, that has to cut through my parabola, and it will be, axis of symmetry will be y equals -2. And I have found all the details for a parabola.